Today I'm talking about the fluid. What is fluid? Normally, when I heard something called fluid, I will imagine that it's a liquid. But actually, liquids, gases, or plasma are considered to be fluids because they can use a shear forces. So, in the picture below here, we can see that um, the solid is not fluid, no fluid, but liquid, gas is fluid in the case. And plasma here, this the D is plasma, it is ion. Okay, what the characteristics of the fluid is density. Density is the mass per unit of a substance or object. The equation is pro equal to mass over volume. Normally, the unit is kilogram per meter cube, but there are another units like gram per milliliter or kilogram per liter or gram per centimeter cube. The density represents to the way that particular of elements of the material organized close together. It means if someone have the flow is large, it means its atom is very close together, extreme large. If the flow is small, it maybe disorganized is will be wider, several is more than each other, something like this. The second term is pressure. Pressure is something one force put on the area perpendicular to the force over which the force is applied. Something like I put my finger on my skin. This is my finger. My skin. I write a force here, put on the area here, and I can find pressure by use the amount of force divided by the area. The unit of the force usually is Pascal. It equals 1 Newton per meter square. Another unit maybe PSI, maybe bar, maybe ATM, or milliliter mercury. Now, we consider the fluid as the rest of the static fluid. In the static fluid, variation of the pressure with depth in the fluid. It means in the different depths, there are the different pressure equally with that. And this equation to find out is one. The pressure equal to the height of the depth times with the flow or the density of the fluid, and g for the acceleration due to gravity. For fluid, the pressure increases with depth below the air for the interface. Yes, but actually the air also the fluid. Yes, but because the density of the air is very small, so we very hard to feel the difference in pressure when we move from the sea level altitude to the high level altitude of the mountain. The pressure is the weight of the fluid divided by the area supporting it. Yes, as you see. So it means the pressure here with S1 and the pressure here with S2 is different. And the P1 may be smaller than P2 because S1 smaller than S2 with the same fluid, with the same density and the same acceleration due to gravity. And atmospheric pressure is one of the cases of the static fluid pressure. Is another example of pressure because the high of the high of the column of air in this case. Due to the weight of air above the given height, the average pressure at the sea level is given by the standard atmospheric pressure (PATM). 1 atm, 1 atmosphere equal to 1.01 times 10 to the 5 Pascal, or equal to 101 kilopascals. Okay. Notice if the object is placed under water, it bears the pressure of the fluid. One is the air above the water, and another is the depth of the water above it. Here, at this point, the pressure put on this point is air pressure, and P normally is 180 on atmosphere. But if we move from this sea level down to this level, the pressure here is equal to pressure of the atmosphere of the water column plus the pressure of the atmosphere. The water we can calculate by rho GH. This one is normally is 0.1 kilopascal. Pascal principle. Definition of the Pascal principle is a change in pressure applied to enclosed fluid is transmitted undiminished to all portions of the fluid and to the wall of its container. This means if we have the pressure of the tile here, every pressure here, if we put one pressure, we move to all the tile we apply. It means P1 and P2 is equal each other. It's 1 and 2 different points in this closed fluid. And we also have the F1 divided by A1 equal to F2 divided by A2 is equal to each other. And Pascal symbol implies that the total pressure in the fluid is sum of the pressure from different sources. What applies for this Pascal is we can use here we can use out some pressure put in here to raise a car which bigger than each other. Very very heavy here because the different in area and area here. F2, F1, F1 and F2. Okay, Archimedes principle of buoyant force. The pressure increases with the depth in the fluid. So the lower point has a larger than the bottom of the object will bear the stronger or the bigger forces, while the top will bear the smaller. The upward force of the bottom to an object in a fluid is greater than the downward forces at the bottom of the object. And when we calculate it, there is a net upward or buoyant force on any object in any fluid. If the buoyant force is greater than the object weighs, the object will rise to the surface and float. This means if we have a ball here and the mass of the ball is we have F of the ball equal to mg. If it's upward, is the buoyant force Fb larger than Fp, the ball will be float on the water here. And if different, we have the heavy thing Fg, it is larger than Fb, and the object will sink in the container. According to principle of buoyant force of an object equal to the weight the fluid is displaced. Here is the equation to calculate it one. Fraction in submerged. The fraction submerged is the ratio of the volume submerged to the volume of the object, and the fraction submerged is equal to V of submerged divided by V of object, volume of object, volume of submerged divided by volume of object, or equal to the volume of fluid here. If we have the box here, submerged particle, this is the submerged volume. Volume of submerged here divided by the volume of is the whole volume of the object. And if the object floats, its mass and the displacement fluid is equal. Now, as the first part of this chapter, we talk about the static fluid. Now we will talk about the dynamic fluid, and we will use the Bernoulli equation to analyze this. The Bernoulli equation expresses the relationship between pressure and velocity in fluids. But there are one limited for the fluid, that the fluid is incompressible and frictionless. The frictionless is really harsh in the real life, but incompressible is mean something like gas. Gas is a fluid, but gas is compressible. So gas can be applied. We can use the Bernoulli equation for gas. But water. The water is fluid, but it is incompressible. So we can apply the Bernoulli equation for water. And in the Bernoulli equation, it states that the pressure plus 1/2 of rho times v squared plus rho g times z and h is constant. It means if we have a dynamic incompressible fluid is still moving, we randomly take 2 points, point 1 and point 2 in this way, point 1 and point 2 inside the fluid, moving fluid. We will measure the total of the sum of the P1 plus 1/2 rho V1 square plus rho ZH1 will equal to P2 pressure 2 plus 1/2 rho times V2 square plus rho ZH2. But the Bernoulli equation can also apply for the static fluid, the fluid in red. This means V1 and V2 is equal to 0 in this case. And the Bernoulli equation will become the P1 plus rho G1H1 equal to P2 plus rho G1 ZH2. And in this case, the Bernoulli equation also includes and express that the pressure due to the weight of the fluid is. Another special case of the Bernoulli equation that what happens if the fluid is moving in the same level of the height. It means H1 equal to H2, and 1 and 2 is 2 different points. In the case, the Bernoulli equation will become the Bernoulli principle. It means P1 plus 1/2 rho V1 square equal to P2 plus 1/2 rho V2 square. With the equation, we can see that if we increase the P1 and we decrease the P2, the velocity in between them will be changed. The V2 may be V3 and V2 1, for example. If the fluid moves with a different diameter here, V1 and here is V2. V1 is smaller than V2, so in this case, pressure in V1 is larger than pressure in V2. Or another way to say is pressure drops at the speed increases in the moving fluid. And there is some application of the moving fluid of the Bernoulli principle. For the exploit the natural gas, we use the air to raise the airflow to either lower pressure inside here, raise the pressure, lower pressure inside here, and make the pressure here bigger than, and the natural gas will move it up. This control apply in the perfume. We have the switch bulb here. When we switch the bulb, the air will moving out with the V1 larger than V2 because the perfume is as the stated. So the pressure at 1 is smaller than pressure 2, so the perfume will moving up and go away to the sprite. Similar thing we can also apply in the water and air and in the chimney and with the heat system here. So that's all for fluid. Thank you for listening.